So in this example, we're going to explore the potential energy of this roller coaster cart as it goes up and down the roller coaster. So a 2,000 kilogram mass roller coaster cart begins at point 1, 15 meters above the ground. Then it travels to point 2, 5 more meters above the ground, and then it jumps down to the ground at point 3. Now we're going to make the assumption that no friction takes place between the surface of this roller coaster and the wheels of our car. We want to find the potential energies at point 1, 2, and 3, as well as the velocity of our car at point 3, making the assumption that at point 2 our velocity of the cart is 0. So let's begin by first finding what the potential energy is at point 1, 2, and 3. So first of all, what is our formula for the potential energy? Well, the potential energy in this case comes from gravitational potential energy. In other words, the gravitational field created pulls on this mass of 2,000 kilograms, creating a potential energy. And it's given by the following formula. Potential energy, or P dot E, equals mass of the cart multiplied by the gravitational field 9.8 multiplied by our height. So let's look at point 1. At point 1 we simply use this formula, so 2,000 kilograms multiplied by 9.8 meters per second multiplied by our height 15 meters gives us 294,000 joules, or 294 kilojoules of energy, of potential energy exists at point 1. Let's go to point 2. Now at point 2 our car goes 5 more meters up, and we're making the assumption that at this point we have a velocity of 0. So at this point we had some velocity because this car needed to rise 5 more meters. And at this point our car begins to drop, so the velocity here we're going to assume is 0. So our potential energy is simply, once again, m times g times h equals 2,000 times 9.8 times, not 15, but now 20. So equals 392,000. So about 392 kilojoules of energy exist at point 2, and at point 1 about 294 kilojoules of energy exist. So notice what the difference here tells us. The fact that this is less energy than this means that some of the energy in this case goes into the kinetic energy. So at this point our cart has 0 kinetic energy because its velocity is 0. But at this point, since our cart is in fact traveling because it needs to get up to this hump, this point, that means it has some kinetic energy. And to find how much kinetic energy the cart has at this point, I simply take this and subtract it from this. So let's find at the third point how much potential energy. Well, at the third point we have the ground, so our height is 0. Therefore, if we plug in 2,000 and 9.8, we have to plug in 0 for the h. So our potential energy at point 0 is, or at point 3, is 0 joules. And what does that mean? Well, since no friction exists, that means our mechanical energy of our system, the cart, is conserved. So if we had no kinetic energy at point 2 and only potential energy at point 2, that means all the potential energy at point 2 was converted, was transformed to kinetic energy in point 3. And that will help us find what the velocity is at point 3. So once again, our mechanical energy is conserved. So our initial, which we're going to assume is our point 2, and our final is point 3, our initial energy is simply the potential energy at this point plus the kinetic energy at this point equals our potential energy at the final point 3, our kinetic energy at the final point 3. So in other words, mechanical energy is conserved because no friction exists, and that means we simply plug in the values on this side and then plug in the values on this side and solve for velocity. So the initial kinetic energy at point 2 is simply 0, and the final potential energy at point 3 is 0. So these guys cancel out, and we find that the initial potential energy is equal to the final kinetic energy. And so we know what our initial potential energy is. We found it at 4.2 right here. So it's 392 kilojoules, or 392 joules. So 392,000 equals our formula for kinetic energy, 1/2 mass v squared. So we bring the 2 over by multiplying both sides by 2, and then we divide both sides by Rm, 2,000 kilograms. And then we take the square root of both sides, and we take our positive to be the velocity. So we get velocity is equal to approximately 19.8 meters per second. So when our cart went from point 2 to point 3, our mechanical energy was conserved, and all the potential energy at point 2 was converted, transformed into the kinetic energy at point 3. And the velocity at point 3 was 19.8 meters per second. At point 1, our object had both potential energy and the kinetic energy. To find the velocity at point 1, we simply find the amount of kinetic energy at point 1. And because no friction occurs, our mechanical energy is in fact conserved, we simply subtract 294 from 392 kilojoules. We find what the answer is, and then we equate that to 1/2 meters times velocity squared. And then we solve for our v, and that will give us our velocity at point 1, which should be less than the velocity at point 3.